Hi class, so in today's lesson we're going to be going over lesson 4, factoring simple and complex trinomials. Again, your homework is listed here. I did have to change it, I'm sorry, it shouldn't say EOL, it should say ACE, so you're going to be doing pages 253 to 255, numbers 1 to 3 ACE, and then 6 to 9 ACE, 10 to 12, and then for the complex one you're going to be doing page 259 to 263, numbers 1 to 6 ACE, and 13 to 14. Okay, so by the end of this lesson, you'll know how to explain the fact that factoring is just the opposite of expanding. You're going to be able to define a trinomial. So a trinomial is represented by something that has 3 terms in it, usually 6x squared, something like this, plus x plus 8, right? Something that has 3 different terms in it, separated by pluses or minuses. You're going to know how to factor a simple trinomial that has the format x squared plus bx plus c is equal to 0. You'll be able to factor a simple trinomial that has a difference of squares. And then you'll also be able to factor a complex trinomial that now is the same thing as x squared plus bx plus c. You just have an a in front of it. Okay? So just to get started, we're going to go down and I'm going to start on our lesson. Sorry, just going to pull this up. So just so that we can go over what a factoring means as well as how to factor. So if you remember from common factoring, the first thing you're always going to do is look for a common factor. So what we did in lesson 3, right? You're going to go and be like, is there stuff that I can pull out of the entire trinomial? And then when you're left over with whatever trinomial you're left over with, that's what you're going to do if there's no common factors and we need to try this other method. This other method is basically many polynomials such as x squared plus 7x plus 12 can be written as a product of 2 binomials in the form x plus r and x plus s, as you can see here. So one thing I want us to understand is that when we're expanding, what we're doing is we're going from the binomial to the trinomial, right? So you're going from those 2 numbers to the 3 numbers. And when you're factoring, you're just going the opposite direction. You're taking the trinomial and you're turning it into a binomial. So you know how multiplying and dividing are 2 inverse operations of each other, as well as adding and subtracting are 2 inverse operations of each other? Expanding and factoring are basically the same thing. It's just one is the opposite of the other. Expanding is the opposite of factoring. Factoring is the opposite of expanding. And we learned expanding in lesson 1 and 2, right? So let's go through and a general understanding or analysis of expansion, right, is when we take 2 formulas, right, and when we take 2 polynomials, what we're basically doing is we're taking r and s, which are the 2 numbers in our binomial, right, so our binomial is those 2 ones, right, and they actually become the 2 like terms that we collect at the end, right? So you know when we go and collect those like terms when we expand a binomial, that's what those 2 like terms, the x and the s and the r, become, right? So when we expand it, so it becomes s plus rx plus r at r times s, right? So think about it when we're doing this. So if we go look at this, let's try looking at this as a FOIL problem. So if I go from x, right, I'm just going to FOIL it out, so it's going to become x squared, which makes sense. That's what that is, right? Then we go from x, we multiply by xs, right, which is what, sorry, I'm just trying to find my highlighter here, which is what this is right here. And then, of course, we're going to do the same thing on the other side with the r, right? So then the r becomes this rx over here, right? And then last but not least, we take the r and we multiply those by the s, and we have this this rs over here. So if we think about it, the 2 terms that we're going to be, you know, collecting together are going to be this sx and this rx. Remember, we always collected that middle term. Another way that you could write this is you could just factor out the x, and then you're left with s and r, right? So then we know that for our b value, right, our b value for a x squared plus bx plus c, our b value is the same thing as writing s plus r. And our c value is the same thing as writing, you'll notice at the end, is the same thing as writing the c, right? So we know that when we have a trinomial, if we're trying to go in the opposite direction, and this is what I'm trying to show you, right? If we're trying to go in the opposite direction, the b and the c, those two coefficients, those two numbers that will be there, are the key for us to figure out what our r and s are going to be, what those two numbers in our binomial are going to be. And I'm going to show you this. We're going to do an example together, which is going to be, let's say I picked x plus 4 and then x minus 4. I mean x plus 5. So I picked these two terms. My r value is going to be 4. My s value here is 5. Let's expand these out. So I'm just going to move them down a little so that we can actually do the expansion, right? So let's expand these out. I'm going to do x times x is going to be x squared. X times 5 is going to be 5x. 4 times x. And of course, if you want to write out all the steps, that's fine. I'm just, for the interest of time, I'm going a little bit faster. Right? And then obviously I have to collect these two. They're like terms. So it's going to be 5 plus 4. 5 plus 4 I know is 9x plus 20. So if I go back and I look at this, my b value here, my b value is 9. And my c value is 20. And it makes sense because r plus s, so r plus s equal b, and then r times s equals 20. And it's always going to be the case. R plus s is always going to equal that middle b value, and r times s is always going to equal the 20, which makes it way easier for us to then expand out and go back and figure out what our r and s values are when we're given a trinomial. So we can go factor in and we can expand, right? So if we realize that they're both the opposite, we can figure out what we should have as our two binomials by looking at the final answer. We can go back and forth. Okay, so when you're factoring a polynomial, right, especially a trinomial in the form x squared plus bx plus c, what you can do is that the first things, there's two steps to do this, right? So steps. And I know a lot of you like having step-by-step process of how to do stuff. This is a great step-by-step process. Step 1 is always going to be find two numbers that add to give you that middle number, right? Find two numbers that add to give you that b value, and then add two numbers that multiply to give you the c value at the end. So find two numbers that add to give you the middle b, and then find two numbers that multiply to give you the c. Personally, I like to do step 2 before I do step 1, just because there's so many combinations that you can get for addition, but there's a limited amount that you can get for multiplication. Another thing to take into consideration is if your b and your c are positive, your factors are more likely than not going to be both positive. If your b is negative but your c is positive, your factors are more likely going to be negative, because when you multiply them together, they'll give you that positive value, but when you add them, they'll give you a negative value. If you have a negative b and a negative c, they're both negative, so one's probably going to be negative and one's going to be positive. And same thing, if you have a positive b and a negative c, one of your factors is going to be positive, one's going to be negative. This is a great chart. Like, I would copy this down, right, and keep for your reference while you're doing your homework, because sometimes like we go through and we do all of our steps and we try to find all of our factors, but if you know, okay, I have a positive b and a positive c, so I'm just going to do the positive values, that's fine then. If you know you have a negative b and a positive c, you're just going to find the negative values. It just takes out like that step of having to do positive and negative addition. Okay, so, and these type of trinomials are always written as ax plus minus s and ax plus minus r. So you just take whatever your s and r values are, and depending if it's negative or positive, you plug it back into that format. Okay? I know this seems really complicated, but we're going to go through and we're going to do a few examples, and then it just starts to make sense, right? So To factor trinomials, we're going to use this table that I like to use. Again, if you're comfortable and you look at this equation and right off the bat you know what your multiples are and you know what your R and S are, be my guest, you can always write them in. More often than not, if you're very good at like division and multiplication, this will make sense to you. For me personally, I do need to make the table myself just because for some it's harder than others, right? Just depending on the numbers. So sometimes I can look at the numbers and just know the answer, but sometimes I need to think about it. So if we look here, we have a negative b value and a positive c value. So if I go back and I look at my chart here, I have a negative b and a positive c, so that means both my factors are going to be negative, right? So I'm just going to deal with the negative values here. If you want, you can do that, but I'm going to go in and for the sake of clarity, I'm going to show you all the possible options we can have. So one possible option we can have is if I did the product needs to be 12 and the sum needs to be 8, and the reason I know that is because my b value is 8 and my c value is my c value b and my c value is 12. Sorry, that took me really long to write in, right? So if I look at this again, I just look at it as x squared minus bx plus c. B is 8 and c is 12. A good way to remember this is b is always going to be the second number, right? Or b is always going to be the number in the middle. B is always going to be the number that has just the x. Okay, so you have, let's find our products. So what products can we find to get 12? So I can do 1 times 12, I can do 2 times 6, I can do 3 times 4, right? And on the flip side, I can do negative 1 times negative 12, and they both have to be negative because it's giving me a positive. I can do negative 2 times negative 6. I can do negative 3 times negative 4, right? Those are pretty much all I can do. So let's just go in and be like, okay, so all of these will give me 12, but which one of these will give me negative 8 if I add them together? So then I like to go in and be like, okay, negative 1 plus 12 will give me 13. So this can't be it. 2 plus 6 will give me 8. I'm looking for negative 8, so that can't be it either. Right? So that's not it. Then 3 plus 4 is going to give me like 7. Negative 1 plus negative 12, and I like to just write that in, negative 12, is going to be like negative 13. Negative 6 plus negative 2 plus negative 6 is going to be negative 8. And negative 3 plus negative 4 is going to be negative 7. So out of all of these, the two numbers that multiply to give me positive 12 and add to give me negative 8 are negative 2 and negative 6. So that means my x value, my r value must be negative 2 or negative 6. It doesn't matter which way you write this. And my s value must be negative 6. So now I can go back and put that in. So I'm going to say x plus r, x plus s, right? And so x plus negative 2, x plus negative 6, and then I can just simplify this to x minus 2, x minus 6. And that's my answer. That's the factored form of that equation. So just to review our steps, the first thing I did was I went and looked at this and I said, okay, what's my c value? 12. I need to make sure I find two numbers that multiply to 12 and then add to give me negative 8. So then I just went in and wrote all my factors of 12 that I have, right, including positive and negative ones. You don't always need to do this. I just did it to show you. But then I went and I added them all together and I saw, okay, which two numbers give me both a negative 12 and a positive 12 and a negative 8, and it was negative 2 and 6. So those became my R and S values, and then I just went and put that in here. Okay. And that is all. So the other thing you could have done was you could have, instead of having to do like the 1 times 12, 2 times 6, 3 times 4, if you went here and you looked at this chart and you were like, okay, I have a negative B and a positive C, I know that both need to be negative, you could actually have just like ignored this entire top part. It's up to you. Whatever you feel comfortable doing, do it that way. Okay? So moving forward, we're going to factor each polynomial fully, right? And we're just going to go through them and talk about how we can approach these problems, and we're going to try to streamline it. So I'll do one with you. So we'll do x squared plus 9x plus 20. And then I'm going to actually have you pause this video and go through 2, 3, and 4 by yourself, okay? So we're just going to do that right now. We're going to go over the product of 20, right? And so what are two things that will multiply to give us 20? So when I say product of 20, it's two numbers that multiply to give us 20. Okay? So let's go through this. We have, and the reason it's 20 is because 20 is C. And then they're going to sum together to give us plus 9, because that's B. Okay? So, two products that give us 20. Let's figure that out. 1 and 20, naturally. Right? And because they're both positive, we're just going to use positive numbers. So, we have 1 and 20, 2 and 10, and then 4 and 5. Those are just the numbers that come to mind. So let's add these together. 1 plus 20. 1 plus 20 will give me 21. 2 plus 10 will give me 12. And then 4 plus 5 will give me 9. The one that I'm looking for is this last one, 4 plus 5. Right? So let's go in. My R value is going to be 4. My S value is going to be 5. And I'm just going to plug it back into this equation. X plus S, R, X plus R. Right? So then I'm left with X plus 5, x plus 4. And honestly, if you were x plus 4 and x plus 5, that's right too. So try doing this one by yourself, right? And you want to take into consideration this is a negative and this is a positive. So the B value here is negative 5. And the product is 6. So if you go back up here and you look, if you have a B that's negative and a C that is positive, both of your factors are going to be negative. So do only the negative ones here. Okay? So hopefully you pause that video and now you're just coming back. Right? So if your product is 6 and they're only going to be negative numbers, negative factors, right? Let's just start off with our negative factors. So we're going to do negative 1 times negative 6, right, is going to give us positive 6. And then negative 2 times negative 3 is also going to give us positive 6. So let's just do the math. Negative 1 plus negative 6 is going to be negative 7. Negative 2 plus negative 3 is going to be negative 5. So we're just going to ignore this right here. So our final thing that adds to give us negative 5 and multiplies to give us positive 6 is going to be negative 2 and 3. Right? So I'm going to use R is equal to negative 2. S is equal to negative 3. Therefore, x plus s, x plus r, right? X minus 2, x minus 3. And again, it could have been x minus 3, x minus 2. It doesn't matter which order you put the brackets in, as long as the brackets have what they need to have in them. Okay? So moving on, we're going to do 3, 4, and 5 together, right? And then I'm going to just go through difference of squares with you, as well as factoring trinomials in the form ax plus bx plus c. So let's go through this one together. So I'm going to show you, like, I use different ways to find them. You don't always have to use that chart. So sometimes what I do is I'll just break them up like this, and I'll be like, okay, I need to find multiples of 3, right? So I just do 1 and 3 and then negative 1. And, I know it has to be negative 3. So I know it's negative 1 and negative 3. Negative 1 and negative 3, and then 1 and 3. This one was easy, right? So then I like to go and be like, okay, so if I did 1 plus -3, I'd get -2. And then if I did -1 plus 3, I would just get 2. So I know that my options have to be this one. I'm basically doing the same thing. I'm just visually showing it in a different way. So x plus 1, x minus 3. Right, taking my r and my s values there. So for these ones, for consistency's sake, I will just do it the same way that I've been doing them in class. So my r times s needs to give me my c value, which is going to be 16. Right, so I'm just going to write that in there, 16. My b value is 8, so my r plus s is going to give me 8. Right, and I always like to do multiplication, or -8, sorry. So notice how this is a -8. So notice how b is negative and the c is positive. So if I go back up here to my chart, let's see what happens. If b is negative and c is positive, that means I'm going to have two negative values. So let's go back down and look at this and say, okay, -8 times 2 could be 1, right? Let's do -16. -16 times -16 will give me positive 16. -2 times -8. -3 is indivisible. -4 times -4. And that's really it. That's all you can really do, right? So then let's go and do the math. -1 plus -16 is going to be -17. -2 plus -8 is going to be -10. And then -4 plus -4 is going to be -8. And you do not need to show me all of these steps. If you figured out like right off the bat that this was -4 and -4, you could have just gone and done that. So I know my r is going to be -4. My s is going to be -4. So my answer is going to be x minus 4. X minus 4. Notice how these two brackets are the same. So I can also write this as x minus 4 squared. Cool. So if you need to, you can pause the video and just write that down. I'm sorry, this shouldn't be x, it should be z, because you want to make sure you're using the variable from the equation. So it should be z minus 4, sorry, z minus 4 squared. Okay, sometimes I forget. Okay, so even here, we're going to do the same thing. We're going to make up our chart, right? And if you want to do what I do with like the 3 different lines, you can do that as well. But I like to make a chart. So I know that r times s is going to give me -45. R plus s is going to give me 4. So let's figure out our factors of 45. And if you look at this and right off the bat, you're like, 1 and 45 is not going to give me 4. Like, I'm not going to even try. That's fine, right? The other thing to notice is that c is negative, b is positive. So if you go back up here, if the numbers are different, right? If it's negative and positive, right? If b is positive and c is negative, it's going to have different numbers. So it's going to be a positive and a negative value for your factors. Okay, so you're going to have a little bit of a mismatch. So let's try to figure this out. Two numbers that multiply to give me -45, -1, +45, +45, right? If I add those two together, I'm going to get like 44. 45 plus times -45 times 1, right? -45 plus 1 is going to be -44. Also doesn't make sense. Let's do a few more. 15 and 3, so 15 times 3, right? 1's a negative. And same thing, I just like to do -3 times 15. -3 plus 15 is not going to give me 4. I'm just going to do the math. Plus 3 is going to be -12. -3 plus 15 is just going to be +12. Right? And then if we break it down even further, we can go to 9 times -5 or -5 times, sorry, +5. -9 times 5, right? So if I did 9 minus 5, I'm going to get positive 4. If I did negative 9 times 5, I'm going to get negative 4. And I'm looking for positive 4. So this is the one I'm going to pick. So my numbers are going to be R is equal to 9. S is equal to negative 5. Notice how it's not negative 5 and positive, it's not negative 9 and positive 5. That's because those numbers will give us a different number in the middle. X minus 5, X plus 9. Or sorry, B minus 5, B minus 5, B plus 9. And that's my answer. So if you're given something that's in the form x squared minus r squared, right, and there's no b value in the middle, right, when you're given something like this, you can basically take it as a factor of x plus r, x minus r. So we call this a difference of squares. It is essentially you're doing the same thing you've been doing before, but the only thing is now when your c value, or that last just the number, is a perfect square, meaning like it's 16, it's 25, it's 4, it's 1, it's 81, it's 100, any of those numbers, right? And there's a subtraction sign in the middle, so the subtraction sign is key, right? What you can do is you can just take the square root of the first one, take the square root of the second one, and do x plus whatever minus whatever. So I'll show you how that works and the reason that it works. So in theory, when you look at something like this, it's actually x squared, and we pretend in the middle that it's a 0, x minus 16. We just really got rid of that 0x, right? So you need two numbers that are going to multiply to give you 16 and add to give you 0, or negative 16 and add to give you 0. So you know that your two numbers that multiply to give you 16, right? One's going to be negative, one's going to be positive. So let's think about it. Two numbers that multiply to give you 16. Negative 16 and 16. Negative 1 and 16. Negative 16 times 1. Negative 8 times 2. 8 times negative 2. Negative 4 times 4. And it's the same thing, right? Negative 16 plus negative 1 plus 16 is just going to be is going to be 15, not negative 15, just 15, right? Negative 16 plus 1 is going to be negative 15. Negative 8 plus 2 is going to be negative 6. 8 minus 2 is going to be 6. Negative 4 plus 4 is going to give me 0. Right? So I'm left with x minus 4, x plus 4. But here's where the shortcut kind of works. I know the square root of x squared is x. I know the square root of 16 is 4. So x minus 4, x plus 4 is going to be that difference of squares. Because I know the plus and the minus 4, when we add them together, will give us a 0. Okay, so you can do it either way, but I like to do it this way. And you have to remember that it has to be a difference of squares. It can't be plus. So let's try doing a difference of squares here. We have x squared minus 1. We square root both of these. So I take r is going to be 1, right? So it's going to be x plus 1. And then just the same thing, but we change the sign, x minus 1. Okay, and that's how you do a difference of squares. You can do the long way if you want. This is just a shortcut. Okay? So, when you're factoring trinomials of the form ax squared plus bx plus c, so they'll look something like this. Not that guy. A can be 2x squared plus 4x plus 8. You're going to follow these steps. So first, look for the common factor. I know that all of these are divisible by 2, right? So I can pull out the 2. And if the form is x squared plus bx plus c, where a is equal to 1, just go back and do what we did, right? Find the product of c and b. Or if it's x squared minus r squared, rewrite it as x plus r, x minus r. So do a difference of squares. Okay, if you can't do any of those, it's not possible to factor. There's a different way to do that, so don't worry about it, but you just ignore them. Okay, so you say not factorable. I will not. I will try not to give you those type of questions. I might give you one on a test or a quiz, but I won't give you many. Okay, so let's do this one. It says factor if possible. So let's see if these are things that we can factor, right? So first things first, let's look at the lowest common number that we can pull out from here, right? So like we did in lesson 3, and it's 2. So I'm going to pull out 2. There's no other x. There's no x here, so I'm not going to pull out an x. I'm just going to pull out just the 2. So if I do 2x divided by 2, and I'll just do it for the sake of clarity with this one, but I won't do them for the rest. 14x divided by 2 plus 24 divided by 2, right? So I'm left with 2x squared, because these cancel out. 14 divided by 2 is just 7, and I'm left over with the x plus 12. So you just divide all the coefficients by 2. Now we can just focus on this inside problem here. So I'm going to highlight this in blue. So we're going to focus on this inside problem here. So I'll do that in blue. So I'm going to leave the 2 on the outside. We'll come back to it, right? So now I need to find something that adds up to give me 7 and multiplies to give me, so r times s and r plus s, to give me 12. So let's think about it. They're both positive, so let's find 2 positive numbers that will add to give me 7 and multiply to give me 12. And for me, right off the bat, I know that's 6 and 1, but if you want, we can go through the process. 12 times 1 is 12. 12 plus 1 is 13. 2 times 6 is 12. 2 plus 6 is, oh, I can't do this. You can't factor this. So this is a not factorable equation, right? Because 2 plus 6 is 8. And then so on and so forth. So you actually can't factor this out just because you have the 7 and the 12 there. And so we can't ever have numbers that when they add up, they give us positive 12. And when they subtract, they give us, when they add up, they give us positive 7. And then when they multiply, they give us 12. So we can't do that. Good, I'm glad I went through it with you. All right, so I'm just going to move this over here. So what I would write at the bottom of this is not even not factorable. You can just write cannot factor further. Okay, so let's move on. Let's do 3x squared plus 12x minus 36. So I know right off the bat I can pull out the 3. Usually I'm going to make it so you can pull out the first number because you want to get that one alone. So I'm left with x squared. 12 divided by 3 is 4. 36 divided by 3 is 12. Right? So now I'm going to try and find 2 numbers that multiply to give me 12. Right? And then add to give me positive 4, and it's negative 12. 2 numbers that multiply to give me negative 12, add to give me positive 4, right? So if it's going to be negative and positive, I know that one's going to be a negative number, one's going to be a positive number, right? So let's think about it. Negative 1 times 12 is going to give me 11, right? 12 times negative 1 is going to give me, that's going to give me negative 11. Oh, it's the same number. So if I do negative 12 times 1, that's going to give me negative 12. But if I add them together, it's going to give me negative 11. Let's go on and do 6 times negative 2, right? 6 times negative 2 will give me negative 12. And then 6 minus 2 is 4, which is positive 4 right here. So I know that my numbers must be 6 and negative 2. So I'm left with 3x plus 6, x minus 2. And that's my final answer. So you try and do 3, 4, 5, and 6 by yourself. So pause the video, go through it, try to do them by yourself. Naturally, I will take them up. at the end of this video, but I do want you to try them by yourself. Otherwise, you'll never know how to do these if you're just watching me go through them. Practice makes perfect. Okay, so do that, and then we can go from there. All right. So hopefully you pause the video and you're just coming back. So here I'm going to go look at my a value. Can I factor that a value out? Can I do 56 divided by 6? Yes. Can I do 120 divided by 6? Yes. So let's pull out the 6. I don't need to pull out any of the x's, so I'm going to do 6x squared divided by 6, 54x, and I'm just going to divide everything by 6. You don't have to write this step in, honestly. You could just divide all of the first numbers by 6 and call it a day, but I'm showing you for the sake of showing you. 54 divided by 6 is 9. 120 divided by 6 is 20. Right, so I like to go and figure out what two numbers will multiply to give me 20. So r times s is equal to 20, and then add to give me -9. So C is a positive, B is a negative, so it's going to be two negative values. So let's find it out. -4 times -5, -10 times -2, and then -20 times -1. -20 plus -1 is going to be -21. -10 minus 2 is going to be -12. -4 minus 5 going to be -9 when I add those two together. So the two numbers I'm looking for are -5 and -4. So then it's going to be 6, which we leave on the outside. And then we're just dealing with this inside bracket. I'm going to change that to x minus 4, x minus 5. And that's going to be my final answer. Then we're going to go and do 4, right? See if we can pull out that 8. Yeah, we can. So then I'm left with x squared minus 7x minus 8, right? So then I'm going to go look, okay, what times what will give me -8 and then give me -7 as well. So r times s is equal to -8, and then r plus s is going to give me -7. I know that if the both of those numbers are negative, one needs to be a positive, one needs to be a negative factor, right? So let's look. -8 times 1, -1 times 8, -2 times 4, or -4 times 2. All of these give me -8. So if I did -8 plus 1, I would get -7. I don't even need to go through the rest of them. I already have my answer. So my two numbers, my r is going to be -8. My s is going to be +1. So I'm just going to go in and say, okay, 8. And then I'm going to replace that trinomial with x minus 8, x plus 1. Sorry, I'm just going to write it at the bottom. It's a little cleaner. 8. And just make sure you remember to leave the 8 out in the front as well. Okay. Moving forward to number 5. See if I can pull out the 5. Yep, every number inside is divisible by 5. So x squared, 30 divided by 5 is 6x, 45 divided by 5 is 9, right? And in this situation, it's either -9 and 1. And if I look at it, -9 and 1 is not going to give me -6. Oh, sorry, I pulled out a -5. So it needs to be positive. So it needs to be -6, right? Because -30 divided by -5 is -6, and then +9. So I have to look at this and be like, okay, either I can multiply these by, and my two factors, the only two negative factors here that will work are -9 and 1, and -3 and 3, -3. Right? -9 and 1 I know is not going to work, so I know it's just going to be 3 and 3. And -3. Right? So I'm going to be left with -5, x minus 3, x minus 3, and I know I can just do x minus 3 squared. Last but not least, number 6 here, we have two numbers. right? First things we're going to find out is, can I divide 300 by 12? It turns out I can, so I'm going to pull out the 12. X squared minus 25. This in here is a difference of squares, right? 25 is a perfect square, x squared is a perfect square. So what we can actually do now is we can just take the square root of the first term, square root of the second term, and we can put it in as 12, we leave on the outside, x minus square root of 25 is 5, x plus 5. And that's our answer. So we don't have to go through all of those steps of finding R and S. It's just easier. Okay. And that is lesson 4 for y'all. See you later.